Hello students, in the last class I explained about a Toots machine that is a pulley and mass system, and you came to know how to find the tension formula and mass, this one acceleration of the system, force on that pulley, right. In today's class I will explain some more examples. These examples especially for your competitive exams. Almost laws of motion, first law, second law, third laws, concepts, everything I explained. And next we have to go for another concept, friction. Before going to that friction concept, so many numerical problems are there in laws of motion. So some example problems I will discuss, and I will continue where I stopped in that last class, a Toots machine. Basically the type of motion is called as constrained motion. Okay, so constrained motion means the body is not free to move in any other direction. It has a restriction for free movement. It has to move in particular direction. Such type of motion is nothing but constrained motion. There is a restriction for free movement. And there are pulley constrained motion also will come, and next wedge constrained motion also will come, then mixed constraint motion also will come, or you can say motion of connected bodies also you can say. So next example, in the next example let us take, this is a block of mass m1. It is connected by the string, and here this is the block of mass m2. This is the horizontal surface, frictionless surface. Then you are applying force on the block of mass m1 in this direction. Because of that force there is a tension developed in the string. This is the direction of the tension. Now definitely if these blocks move with some acceleration a in this direction, means this body also move with same acceleration. So we will find what is the acceleration in the system, right, and also what is the tension developed in the string. So this type of motion, it is nothing but a constrained motion. It is the restricted for free movement. It has to move in this direction only. Where you are applying the force, in that direction only it has to move. Then first what you have to do, you have to draw free body diagram like this. I hope you understood how to draw the free body diagram. M1 mass, this is the FBD for M1 mass, and this is the FBD, free body diagram for M2 mass. Then on this mass, this is the force acting, and in this direction tension force is acting on the string, right. Then the acceleration is in this direction a. If we see for second mass, only one force is acting in this direction, that is tension, and the acceleration is in this direction, a acceleration, isn't it? So like this you have to identify the forces. And then next what you have to do means, you have to write the equation, that is Newton's second law of motion, you have to apply. So it is moving in this direction, means F minus T is equals to M1 into A. And here only one force is acting, right. This is only producing the motion, acceleration in the body. T is equals to M2 into A. Then T value you shift here, F minus m2a is equals to m1 into a, or f is equals to, you can write it as m1 plus m2 into a. Then a value, we came to know that f divided by m1 plus m2. So this is what? Acceleration of the system, f divided by m1 plus m2. Suppose in the exams they may give this is 2 kg block, this is 1 kg block, this is also, let us take 2 kg block, then you are applying force 10 Newton, then find the acceleration of the system, means like this you will write, then finally the force is 10 Newton, 10 divided by 4, the acceleration you will get, that is 2.5, isn't it? In like this you have to solve the problem. So this is the acceleration. Then we have to find the tension in the string. To find the tension, T is equals to, how to find that value? Here we have T, any one expression you take, this is easy, right? I will take this one, T is equals to m to a, then T is equals to m2, and a value is f by m1 plus m2. Then this T is equals to, you can write f into m2 divided by m1 plus m2. This is the expression for tension in the string. And see next application. So today's class I will explain these applications only. So this is the roof, and here this is a string. This block, let us take it as mass m1, and another block, let us take it as mass m2. So you are applying some force. So one string, in that string the tension is same. Here we are using two strings, right? So whenever in the problem there are two strings, then you have to consider the tensions are different. For this first string tension is T1, and the second string, let us take the tension is T2. And now we have to solve the problem. That means it is not moving anywhere, right? This is at equilibrium, it is not moving, you are applying force only. Then I will take this block, that is mass m1, this is mass m1. On the block mass m1, observe carefully, here it is not in contact with any surface. In that case you have to consider its weight, m1g, acting downwards, and plus you are applying force, that force is F, and in upward direction the force acting is tension force, that is T1. This is the forces acting on the block M1. Similarly, free body diagram for block, this is block M2, right? This is weight M2g. Similarly, the free body diagram for mass M1. M1 weight is acting downward, M1g, and tension force is also acting downward, T1. In above direction, tension force, that is acting T2. Like this we have to identify the various forces acting on a body. And next step is writing the T equation. So downward force, upward force, there is no acceleration. Directly T1 is balancing by M2g plus F. That means downward forces are M2g plus F. This is balancing, means both are in equilibrium, means we can write M2gF is equals to T1. Acceleration is 0, means net force is 0, means both are equal. T1 is equals to M2G plus F. So here M1G plus T1, M1G plus T1 is equals to, you can write it as T2. Then this is what the value of T1, right? T1 is equals to M2G plus F, and T1 value you shift here, you came to find the T2 value. That T2 value is, I can able to write M1G plus M2G plus F. This is a T1 value. This is equals to T2, or T2 value I can able to write it as G into M1 plus M2 into G into M1 plus M2 plus F. Okay. G of M1 plus M2 plus F, that is the value of T2, and attention T1 value is M2G plus F. In this way, we have to solve these problems. And next application, let us consider an horizontal table, a frictionless table. Here there is a pulley, and here there is a block. This block of mass, let us take M1. It is tied by a string, and string is rolling over on this pulley, and here there is another block. This block mass is M2. Let us say M2 is greater than M1. So the acceleration is downwards. Only one string. So tension throughout the string remains same. Tension, let us take it as T. Now you have to find what is tension force in the string and what is the acceleration of the system A in this given condition. M1, mass M1, identify the forces. So whenever there is contact, right, in this case this normal and mg both are balancing, no need to take those forces. Here M1, the force acting is T, only one force, then T acceleration in this direction, right, this is the acceleration, the block is moving in this direction. Then T we can write it as M1 into A. And next second block, this block is M2. M2 acceleration is downward. So here I can able to consider the weight M2G, and in upward direction tension force is acting T. Then acceleration is downward, means we can write M2G minus T is equals to M2A. Now this T value you shift here, M2G minus M1A is equals to M2A, and M2G is equals to M1 plus M2 into A. You can write our acceleration is equals to M2G divided by M1 plus M2. This is the formula of acceleration. So to find the tension, T is equals to M1A, here only it is there, right, directly I will write T is equals to M1, A value we calculated, that A value is M2G, that becomes M1 M2G divided by M1 plus M2. This is the value of tension in the string M1 into M2G divided by M1 plus M2. And then here we can also find force on this pulley, force on this pulley, I can able to write like this: one tension force acting in this direction. This is force on the pulley I am representing. So another force is acting in this direction. That means this is one vector, this is one vector, this is the resultant vector, right? So this resultant vector magnitude by parallelogram law of vector addition, the angle between them is how much? The angle between them is 90 degree. So a square plus b square plus 2ab cos 90. Cos 90 becomes 0. In that way, we came to know that force expression is equals to, I can able to write, so this is also T, this is also T, means T square plus 2T square cos 90, that becomes 0. Then this equals 2T square whole root, or you can write F is equals to root 2 into T. This is the force. Then in the next example, let us consider an inclined plane or wedge. So here it makes some angle theta. Now what you will do, you will place a block of mass m. So frictionless surface. You can consider as this is a wedge constraint motion. Then what happens here? Definitely you know that the block will slide downwards. For that some acceleration is needed, right? So we will see what are the forces acting on the block and which force is providing motion in the object. So no one is applying force, right? Then in this plane you observe, so this is the block mass m, and in this case mg normal always acts vertically downward. Mg weight always acts vertically downward direction. But this is the contact surface, means normal force in which direction will act? Normal force will act always perpendicular to the contact surface. Okay, this is the normal force acting. The direction is perpendicular to the contact surface. Previous cases in horizontal surfaces, okay, in horizontal plane, in this case balancing mg, right? Hence we are not showing when the object is placing on the horizontal surface, but in this direction here normal is not balancing this mg. So in such a cases what we have to do means we have to resolve this mg vector. Out of two vector, one vector we need to resolve to get the balance. So how to resolve means, that is, if this is the vector, force vector, means we can find its effect in any other two direction. Suppose it is acting in this direction, right? My interest to see what is the effect in this direction. In that direction we have to consider one of its component. Then other direction should be perpendicular to the first direction. This is the rule. This is the method. One vector is acting means in other two direction we can find its effect. First we have to choose one direction. The next direction should be perpendicular to the first direction. Here also I want to see its one of the component. I will take one of the component exactly opposite to normal reaction. This is one component, and another component should be exactly perpendicular to the first component. In such a way we can resolve. Then we will see in this diagram, this angle is theta means this angle also will comes to be theta. That means contact force, that normal force acting normal to the contact surface, weight is acting vertically downward, both are not balancing now. Hence I am taking one of the component of the mg in this direction and another component is perpendicular to this component. Then this angle is theta means this angle also will comes to be theta. Observe the diagram carefully. So if you extend this line and if you extend this line means this angle becomes 90 degree, right? This angle is 90 degree. Then in this triangle this angle is 90 minus theta, isn't it? In this triangle this is theta, this is 90 degree, this is 90 minus theta. So this line and this plane again perpendicular. Then this angle is 90 minus theta, this total angle is 90 degree means definitely this angle also will comes to be theta. That is, in this diagram this angle becomes theta and theta side always cos component mg cos theta. Like this we defined this component is mg cos theta. If this angle is theta, then in the diagram this angle also will comes to be theta. So this is mg cos theta, horizontal component, and this is vertical component, that is mg sin theta. Now you can observe carefully. This is mg cos theta and this is mg sin theta. For mg cos theta exactly opposite normal reaction is there. Normal reaction mg cos theta acting on a single body, that will get cancel each other. Okay, they will balance. The body will not move in this direction or downward direction, right? They are balancing each other. But to balance mg sin theta, is there any force in the opposite direction? Definitely in the opposite direction no force is there. Hence mg for sin theta acting downwards, this unbalanced force, these will balanced. This is not balancing. Why? Because no other force acting in opposite direction. Unbalanced force always creates motion. So here mg sin theta force is responsible for the block sliding downwards. So this is very very important. Next the example problems will come from these concepts only. Wedge constraint. Hence I explained briefly. I hope you understood. So mg sin theta force means what is the acceleration in the downwards? So force is equals to mg sin theta, that is downwards, then mass into acceleration is equals to mg sin theta. The block is moving downward, right? Then m and m will get cancelled. The acceleration in this direction is g sin theta in frictionless surface. There will be no friction between block and mass. In that time the acceleration of a block coming downward, that is g sin theta. And based on that, see one example problem. There is a wedge. This is the wedge. This angle is theta. There is a block of mass m1 and here there is a pulley, and this block is, this string is rolling over this pulley, and another one block, this mass is m2 and the acceleration is downwards. So this block will move in this direction. You can consider m2 is greater than m1. So in this case here only one string we have used, hence tension will remain same throughout the string. We have to find the acceleration, tension forces and force on this pulley. So in this case, first I will draw the block diagram for mass M2. M2, that means weight acting downwards. That weight is M2G. Tension is acting upwards. The tension is T. And next one, right now I will write the equation also. Then I can write M2G minus T is equals to M2A. And I will write the free body diagram for block M1. This is mass M1. Here the weight will act downward, M1G, and in this direction tension force is acting, isn't it? And here in this direction normal force is acting, and in this direction mg cos theta, that means one of the component of this block is acting. Why? Because this angle is theta. And in opposite direction, which component will act? Which component will act? Mg sin theta component will act. Just now I explained. These n and mg equal in magnitude, opposite in direction, both are balancing. Hence the block is not moving upward or downward. But the block is moving in this direction, right? That means these two forces are not balancing. T is greater than mg sin theta. Then here how to write the expression? T minus mg sin theta. T minus mg sin theta should be equals to m1g sin theta should be equals to m1 into a. This is the equation for the second diagram. Then if we solve simultaneously, I will write this one. T minus m1g, this is m1 g sin theta, m1g sin theta should be equals to m1 into a. Directly this minus t and plus t will get cancelled, and here if you see g, if I take common outside, I can able to write m1 sin theta, or I can able to write m2 minus m1 sin theta is equals to m1 plus m2 into a. Then acceleration of a system A is equals to, I can able to write it as g m2 minus m1 sin theta divided by m1 plus m2. This is the acceleration of the system. In this acceleration, these blocks will move. And next we have to find the tension force, isn't it? For that, to find the tension force, I will take this expression. So m2g minus t is equals to m2a. m2g minus t is equals to m2. A value is g m2 minus m1 sin theta divided by m1 plus m2, isn't it? You have to solve this step to find the value of t. Then t is equals to, you can write it as m2g minus m2g of m2 minus m1 sin theta divided by m1 plus m2. Then t is equals to, you can take m2g common outside. If you take m2g common outside, here it will becomes m1 plus m2 minus m1 plus m2 minus m2 plus m1 minus m2 plus m1 sin theta divided by, whole divided by, okay, m1 plus m2. Then here plus m2 minus m2 will get cancel. Plus m2 minus m2 will get cancel, and t value is equals to m1 you take common outside. If you take m1 common outside, it will become m1 into m2 g 1 plus sine theta divided by m1 plus m2. So this is the tension in the string or tension in the thread. So I hope you understood these application especially for competitive exams. So practice these applications. Thank you.